Welcome to Easy Maths. In this particular video, as we go on to do concepts on surds, I want us to focus our attention on operations of surds. In this case, we're going to deal with the addition, subtraction, multiplication, and division, and therefore let's just get to it. So in the first case, we're going to deal with addition and subtraction since they go together or they behave the same way. We are given some 4 questions here, and the whole idea is we simplify. You see, root 3 plus root 3, or 5 root 3 minus root 3, and the 2 others there. I need to say this as we begin. Please note that a surd can be looked at as though it's an unknown, and that's what you're going to use to do this part about addition and subtraction of surds. And that means, for example, if we have root 3 plus root 3, if we let root 3 be x, we are talking about root 3 plus root 3 being equal to x plus x, which is 2x. But you know that x was root 3, and therefore the answer for this is 2 root 3. Maybe another way you can look at it is we are talking about root 3 plus root 3, which means something times 2, or something plus itself. If it was root 3 times 2, then it would be 2 root 3. And I need to explain that this, therefore, is how we do addition of surds. It's like factorizing out, and you ask yourself what is common. You put out root 3, and then you have 1 plus 1, which is 2 root 3. Now, if we have 2 root 3 plus root 3, again, it's the same way. If root 3 was an x, we'd be talking about 2x plus 1x, or x if you like, which would be 3x, which would be 3 root 3. Again, it's done in a very similar way with the first question there. Moving on to the third question, which involves subtraction. We have 5 root 3 minus root 3. It's like if we have 5 things minus 1, would have 4 things, and therefore it would be 4 root 3. If root 3 was an x, would have 5x minus x, which would be 4x. Where x is the root 3, and therefore the answer should be this way. What about the last question, which is a little different? We have 2 root 3 plus root 5. If we let root 3 be x and root 5 be y, therefore we're talking about 2 root 3 plus root 5 being 2x plus y. And you see, 2x plus y, since we don't know what x and y are, that expression is the best way it can be. And that means this remains as it is. And I need to conclude that by saying the expression, this one here, is in its simplest form. The reason is we're talking about 2 different surds, root 3 and root 5, which cannot be combined by addition or even subtraction. Moving on to the concept of multiplication and division, we have some questions that I want us to attempt, and so we have the first one there. Root 3 times root 3, what is it supposed to be? Something times itself, it's the thing squared. So root 3 squared should be, obviously the answer should be 3. But you can also approach it this particular way. Root 3 times root 3 is the same as 3 times 3, all of it under square root, which is square root of 9. Square root of 9 is 3. And therefore, approaching it from 2 different angles or sides, the answer should be the same. Squaring something, that is, in this case, root 3, means the square and square root being reverse operations. They take away the square root and we remain with 3. Similarly, we can approach it the way I've done it there. That is, root 3 times root 3 is the same as square root of 3 times 3. That is square root, then 3 times 3 within the root, which is square root of 9. That answer, the answer there would be 3. What about if the roots are different, like root 3 and root 2 multiplied together? The product of that would be the same as this one here, which is root 6. Remember, this operation is not possible for addition, and that's what we attempted in the first part. For addition and subtraction, we cannot combine these two under the same root, but for multiplication and division, it's possible. Now, checking out this other one, which is again 2 mixed surds, 4 root 3 and 2 root 7 multiplied together, we multiply the 2 rational numbers together, 2 and 4 and 2, which is 4 times 2, and the numbers within the roots 3 and 7 together that particular way, and therefore the answer will be 8. That is 4 times 2 is 8, and 3 times 7, 21. That is 8 root 21. So whenever we have a question like this, multiply the rational numbers together and the irrational ones, that is the numbers within the square roots together, and you get the simple form like the one we have there. Now, I need to say that whenever we are given m, root m times root n, the answer simply would be square root of mn, like we've done in the first two cases here. However, if we had a mixed surd, like a root m times b root n should be ab root mn. That's what we've done in the last case there. Moving on to division, we have root 3 minus divided by root 2. It will be the square root of 3 all over 2, and that's the best we can write. That's how it should be. Remember, for addition, multiplication, and division, we can combine the numbers with that operation, that is square root in this, division in this case. 3 divided by 2. 4 root 15 plus 2 root 3. Again, please notice that the rational numbers are divided together, like 4 divided by 2 this particular way, and then the square root of, that's 5, square root of 15, and square root of 3. Since we are dividing the two of them, is them as square root of 15 over 3, which we have it this particular way, and therefore the answer will be 2 root 5. 4 divided by 2 is 2, and root 15 divided by 3 is 5, but all of it has square root, and therefore we have it this particular way. And therefore at that point we need to say the following as we close the lesson. Let me say that root m divided by root n is same as root m over n. That's like we did in the first case here. And as we did in the second case, we have a root m divided by b root n. It means a over b root m over n. And therefore that brings me to the end of that particular lesson. Check out for what we have more, again, as we continue to build this concept of surds. Thank you.